Okay, so welcome to today's webinar. I'm Gary Archer from Curity, and I'm here with my colleague Judith Kara. And today we're going to explain some strategies for connecting AI agents to APIs and controlling the level of access. A little bit of background on Judith and myself. So we produce a lot of teaching material at Curity. So we provide tutorials, integrations, articles, that type of thing. We're also the authors of this book, which is very relevant in the world of AI, because typically what you want to do when you're doing AI and API integrations is to grant the AI agent some level of access, but not too much. So therefore, you need to understand this concept of least privilege, which we're going to talk about a lot today. So let's start off by talking about how AI and APIs intersect. So I'll hand over to Judith.
Yes. And the subtitle of this section is interoperability is key. Because when you have those AI agents and those autonomous applications, they need to connect to each other. And for that to work, you need some standards. Gary, next one. And there are already some standards like MCP, Model Context Protocol, or Agent-to-Agent Protocol that do that allow those applications to interact with each other. And there are probably a lot of more protocols evolving. But we're going to focus on mainly MCP today, though you can apply it in general as well.
In big news in 2025, you probably heard a lot about MCP. So
yeah, and interoperability is also important for security. And when I talk about security, I mean, you need to authenticate humans, the users, you need to authenticate the applications, the agents, and to give them least privilege access to the APIs and essentially to the business data. And as I said, if you have those standards to connect the agents, you also need standards for the security part, because otherwise it's not going to be a secure connection. And that's where OAuth comes in. OAuth provides the end-to-end security. So it's an architecture that enables defense in depth. It's vetted by, or it has vetted an interoperable security standards. And the nice thing is that the community keeps up to date with the best practices. Yeah. And sorry, Gary?
No, but very much so, because OAuth considers, security of each environment, and especially APIs, and it's above all else, it's about API access. So it's the security standard that deals with authorization in the most complete way.
Exactly. And MCP actually writes an OAuth profile. So they have integrated some OAuth parts in their specification, in the MCP authorization specification, that discusses things, how to discover the authorization server, how to establish trust. And if you have that in place, you can then run basically standard OAuth flows, like the code flow, where you can authenticate the user and collect the consent, authenticate the client, and at the end, get that access token that gives the client this least privilege access to the API.
Yeah, and I think, as you said earlier, Judith, I think when you look at this picture, what's different in the world of AI is that the MCP client is not something you write yourself or you can control very much. You can't control its code, and so you have to be interoperable, right? So in the old days, if you've got an API, you can tell people this is what you have to do, but it's not quite so easy. Well, I mean, you need to consider interoperability more in the world of AI, right? So
yeah.
And what often gets neglected, I think, in these things is the details of the access token. So what the details the access token allows are all important, really, and that's probably the most important outcome. So we'll talk a lot more about that today.
Exactly. We're going to focus a lot on the access token, but also a bit on the established trust and the things around it. Next slide. So in the context of authorization and secure access, AI agents are another type of API client. So in OAuth, we have web applications, we're used to mobile applications, we're used to B2B clients, and now we also have AI agents with their MCP client. So this is pretty similar to what we already do. And that's why OAuth fits so good into the picture. So if we take
Probably a good point to mention. I was thinking this in some ways, like there are existing architectures, and many organizations have 10 years or more of investment in APIs, and to use to integrate AI in MCP, you don't need to rewrite all of that or anything, but all you should need to do is have a new entry point, the MCP server, and maybe do a bit of thinking about your existing security as well. So it doesn't have to be a huge rewrite or anything, does it?
No, exactly. That's what brings us to the next slide.
Yeah.
If we go to that one, Auth is pretty cool because it's file adapted. You don't need a lot of code to get integrated. They're like good support for libraries that do most of the stuff for you, and you're probably already using it. So what you need to do to integrate this new type of client is to review this architecture. So you don't need to have a big bang migration and reinvent everything, but you can adapt what you have for these new use cases.
Yeah, it's a good time to, as we say in the next section, is to review your architecture. So there's some particular behaviors you should understand, often things that are missing in existing API architectures that you're going to need for AI integrations. So what you'll often find is that a lot of systems have, fairly careful API authorization. We know there are some gaps, but typically APIs make sure user A can't get user B's data, sort of thing. And that's fine, but many APIs they have some gaps in areas like providing APIs with sufficient information to authorize correctly and setting boundaries on API access. Very important to set boundaries so that AI agents don't get too much access. So often what you get with APIs is a people problem, really, where there are these technical things called access tokens and token issuers, etc. But the people don't really understand the level of access. So I was speaking to an organization earlier this year, and they just didn't quite know what their APIs did, and they were concerned about exposing them to AI agents, and that we spoke about a plan of action. So I think many organizations have this kind of state to some extent, to one extent or another. And so really bringing a bit of organization around your API and data access is a good aspiration. And really, it's all about the access token. You can think of an access token as the secure gateway to your business data. Obviously, you get things like API gateways that can do simple allow or deny access, but real data is not like that. Typically, you need to grant partial access, and that's what most organizations want to do with AI agents. So if you control access tokens properly, you can control the level of access, the time of access, and get those right behaviors at the API level, and very much simplify what API developers need to do. So here's a very simplified picture of a AI agent to API flow where this uses MCP authorization, and we're not showing MCP components in this picture, but essentially the AI agent triggers user authentication. The user authenticates themselves, consents to the AI agent's level of access, and the AI agent can then send an access token to APIs and work with sensitive data. So the basic flow, I'm sure most of you are doing this in one form or another already, but the devil is in the detail of the access token, really, making sure that you have the right kind of human approvals, that the access is least privileged, so that the AI agent can't do things you don't expect it to do, and also give APIs the runtime context so they can make the right decisions. So the first big ingredient is scopes, and what scopes do is they set security boundaries, so you can immediately deny access to various types of data to AI agents, so you can give them a limited scope of access. And scopes also have interesting behaviors in terms of people understanding as well. So a good way to deal with scopes is to think of it in terms of partitioning your business data in terms of area and data sensitivity. So here's a few examples that you might get started with for retail and commercial areas of the business, for example. And you might have a couple of high privilege scopes here, like legal contracts or whatever. And if you don't assign these scopes to AI agents, they can't access that data, right? So that's a good first level of defense. And probably more importantly, I think this can help people to understand what access tokens do and what levels of API access represent, because these kinds of domain keywords, most people in the business should understand them, like not just developers, also business analysts, product owners should have an understanding of these keywords. So typically what happens is that in an MCP authorization flow, an administrator such as a security team member or someone who understands security would grant AI agents access to certain scopes but not others, and that restricts their API access. And another important ingredient here is that scopes play a part in consent screens. So in this example, we have a fictional kind of financial use case where the AI agent gets some read-only information to stocks, such as the user's portfolio of stocks or something. And so the user consents to this area of data. So this might be a financial employee or something. And there's some other values here. These are called claims. So for example, there's a region which restricts the level of access to that user's country, perhaps. And also there's an account ID which restricts access to information that particular user is authorized to see. So scopes should be understandable, and as we showed here, there's both scopes and claims shown in this consent screen to the user. And claims are what enables the most detailed authorization. So we're going to talk quite a bit about them. But before we do that, Judith's going to talk about the requirements, I guess, for claims, so that you can think about how you design the claims. And this is really the world of authorization and policy, etc., right, Judith? So
yeah, exactly. So it's not just enough to plug in auth or plug in this new AI agent to your auth infrastructure, but you have to review the rules. And that means, if it gets to the next slide, that means at first you need to understand the impact. And to understand the impact, you need to understand the use cases. What is this AI agent supposed to do? Is it a first-party agent? Is it a third-party agent? What are the associated risks? And how does that affect the access control policies? And that means, if you go to next slide, that, for example, means answering questions like, how do you configure the trust for the AI agent? For first-party AI agents, you said that it's probably mostly going to be third-party, but people or organizations may implement their own MCP clients or AI agents, and then you can pre-register them, for example. Or you may use something that's pretty new, is the client ID metadata, which is just like an HTTPS URL that you trust. Or you can have dynamic client registration, but whatever suits you depends on the use case and the associated risks. And based on that, you have to decide what are the scopes that the AI agent is allowed to request. It doesn't mean that they're going to grant it. That's a different thing, because you may have the user involved saying, well, the user and the user could deny a request. But in general, what is the most that an AI agent could do? So all of that depends on the use case, on the risks, and on your needs. And on top of that, then, if you go to next slide, thank you, is a runtime authorization. So once the client or the AI agent gets an access token, you have to decide, do I need AI agent specific rules? You probably do, because AI agents behave differently than other applications. They are unpredictable, they can they are more autonomous, they can come up with new requests. So you need a way to identify the AI agents. And then when you get the request, you also probably want to know if that actually is an intended request? Is that really something that the user wants the AI agent to do? How can you increase the confidence? And that's where, next slide, Gary, please.
Yeah,
That, no worries. That's where claims come in, and the user consent that we have seen before. So users can consent to the scope and to the claims. And the claims is what you put in the access token. So claims are asserted verifiable values in the access token. And APIs then verify the access token, they get the claims, and they use that for the access control policies. And when I say the APIs use that, it doesn't mean that you hard code those rules in the APIs. It could be outsourced to an external authorization management system. But the main point is that you have those verifiable claims, you have all the information or most of the information that you need with regard to the identity of the user and the identity of the client in the token. So those claims, if you take the next slide.
And that's important as well, too, because, often we've seen like insecure practices, like people passing secure values in HTTP headers and that sort of thing. But if you receive them in a token, they can't be altered. So, no one can lie about, I'm not an AI agent or something like that.
No, exactly. The token is signed.
Token.
Yeah, the token is signed, so it's integrity protected. So it means that you can't just manipulate them.
So some of these practices, like sending secure values in plain HTTP headers, could possibly be exploited by a malicious agent, whereas the tokens can't be because they're cryptographically protected, right? So
yeah, exactly. So it's a much nicer way to send this kind of sensitive data to the policy enforcement points, to the APIs. And this kind of data that we call identity data, it can come from various points. So with regard to the user, they can come from the login, from the business partners, the wallets, the workforce identity, or they can also come from internal data sources of the authorization server. They can have their own user store and load that, or like complement the data that they got from the federations. And they can also come from the clients, the AI agents, through the authentication, method, some certificate, or anything else, the HTTP URL, something that's going to identify the AI agent can also be used as a claim. And those claims result or end up in the access token that you can then use for the access control policies. Yeah,
I think this is quite an important slide, and I know we're going to talk about it in the next slide, but let's come back to this in a second, because it's something that's often not understood by people about the role of an authorization server, actually. I know you have some details here that you could talk about, Judith. So.
Yeah, I think I mentioned most of that, but the authorization server is the one that collects all the attributes, and it first determines which attributes do we need. So there's a contract between the API and the authorization server, where the authorization server needs to know which data, which attributes, which claims to include in the access token. But it retrieves those claims and the values and puts that in the access token. And as we have seen in the previous slide, it uses different standards to collect that data. And then and that's important. Yeah.
If we go back to the previous slide, so sometimes these external systems like to get information about users from business partners. Often you have to go through like federated security standards to get hold of that information. Like this user from a business partner has this role or something. Those kind of things. Or attributes from users' wallets or that type of thing. To actually get hold of these values requires security standards, and this is where one of the big roles of the authorization server. And so the authorization server can collect these attributes and issue them to access tokens. And when it does so, one best practice that we recommend is that the authorization server issues an opaque access token to the AI agent so that it can't read those values, because the values in access tokens are intended for APIs, right?
So when we say that it puts this information, the access token, it doesn't mean that it's like makes it available in the access token. It's just it associates this data with the access token, but it doesn't mean that it sends all the data to the agent, because it can be, it can be some sensitive information. It can be information about your partners that you don't want an AI agent to know, especially not if it's a third-party agent that you can't control, where such information could potentially, through a vulnerability leak. So it's more secure to use an opaque access token and use something that we call the phantom token flow to exchange that. And I think we have a slide on that as well.
Yeah, so let's
Yeah, exactly. So here we show that instead of returning all this data to the AI agent, you have an API gateway that exchanges this opaque access token to a dot access token that it forwards to the API. So the API has all the information that it needs for the access control policy. So in this case, we also see an example that indicates that this request comes from a client that's an AI agent with a client type AI agent claim. But there's basically no limitation on which attributes you include in the access token.
Yeah, you should be able to design anything that makes sense for your use case, and this is why OAuth isn't an out-of-the-box solution. You can design based on your use cases and whatever makes sense, because when it comes down to it, every business authorizes access to data differently because they all have, slightly different requirements. But what's quite interesting here is what this enables an API to do. So in this example, we actually have an American administrator from a business partner in these attributes, and he has access to some kind of commercial orders scope. And usually that user might have access to 10 or so operations, but in an AI context, you might only want to allow access to, say, 3 operations, right? So therefore the API developer can easily adjust the authorization based on the presence of these extra attributes about the client, and so that's a good approach to use for your AI use cases. And it's pretty simple to do. The AI, API developer has a pretty easy job. So
it allows you to adapt the policy, no matter if it's for AI agents or any other attribute that's important. But you can adapt it and have like different rules for different scenarios, basically.
Yeah. So this is in some ways this is where you want to get to with AI and API access, that you go through all of those security standards like the MCP authorization flow, but at the end of it, after all the user actions, the APIs have full control over the level of business data, and they have the claims they need to implement the authorization, right? So not too difficult. OAuth is always like this, that you spend some time on the design, and then the actual coding tasks are straightforward at the end of it.
Yeah. And you have prepared some demo.
Yeah, we actually have a small demo here just to show you how to get connected. So I'm going to come out of this presentation a second, and I'm going to run Claude Desktop. And this example is something that you guys can run yourself. Anyone, if you want to see how to connect AI agents to, if the demo gods are with me, there you go. So over here, it's spun up a window that Claude Desktop is requesting user authentication. So this is a fictional financial use case. I'm going to go to a mock email inbox, get a one-time password. So the user authenticates. Here's the consent screen we showed you earlier. So the user consents to those details. And at this point, my API or my MCP server is connected to Claude Desktop. You can see there's an MCP server here. What I did earlier is I entered the URL of the MCP server. And here I can just ask a natural language question like, let's stop prices or something. And the MCP host, in this case, Claude Desktop, can go off and it can inspect the tools that are connected. Taking longer than usual, this is not a good sign. This is a typical demo. This is not usually. Mhm. Well, this is not what I had in mind. Let's try that again. There you go.
Yeah.
So we had a bit of a blip there for some reason. I don't know quite what was happening there. But the idea is that the user approves access, and Claude goes off and calls the API now.
Yeah. So we have an MCP server with a tool that calls APIs, and that requires an access token. So that's what's happening in the end.
So this is just a getting connected example. We on the Curity website, we'll be publishing a more interesting example in the next couple of weeks or so on a step-up use case. You know, how do you manage getting stock information and then stepping up to a higher privilege operation to buy stocks. So we're going to have an example that does that in the next,
Yeah.
in the near future.
But you can also see here on the results that it says USA, and that comes from the region claim, right?
Absolutely.
So if we would log in with a different user, or if a different user would connect to the MCP server, they may have a different list.
Yeah. And you can also filter the operations returned to each user depending on the claims as well, right? So hopefully that gives you an idea of how it all fits together. If you'd like to run that demo, you can.
Yeah, we have a link at the end.
Yeah, it's a GitHub repository. You guys can run it yourself. So and it shows you how to get connected. And the thing to notice about it is that the API is in full control of the data it exposes, and the API developers have a straightforward job. So really, that probably the main thing we wanted to emphasize in the webinar is about scopes to set security boundaries and claims to enable the fine-grained authorization. And with those two ingredients, your APIs are in a great place and you can control exactly what information and operations you return to AI agents. But there are some additional patterns that you should be aware of that are very important in the world of AI as well. As for the techniques we've seen so far, these are all building blocks that you can apply depending on your use case. So the first one we're going to talk about is strong AI agent client credentials. So AI agents can potentially run in multiple locations. They can be a chat kind of example that I just showed you, Claude Desktop, or they can be potentially run within your backend or something. So for years, Curity have been recommending these ingredients of use strong client authentication when you can and protect all of your APIs using a zero trust model. When it comes to strong client authentication, these days there are solutions like workload identities like Spiffy and Spy you've probably heard of, and various ways in which the AI agent might be provisioned with a strong identity. And this can contain attributes. As we showed in that diagram earlier, the client itself can send a workload credential with attributes that identifies itself. And there's a general pattern here of sending what I sometimes refer to as a token for authentication, and then you get back from the authorization server a token for authorization, the access token. So when you can, give the AI agent a strong client identity, such as a workload credential. You can use things like Kubernetes service account tokens for this. There's options in AWS in various places as well. And the idea is that you then have high confidence that the correct trusted AI agent is present and that you're not being called by a malicious party. And if you go,
Gary, one question.
Yeah.
What happens now? We are talking about AI agents, but there's also often a user involved. So we have a question about what about calls from already authenticated applications? say, agent applications already authenticated in some enterprise IDP and wants MCP to work on the identity of this already authenticated user.
Let me
So
see if
you
I can
have
digest that.
so the user already authenticated via an IDP. So they logged into the AI agent with through an IDP. So the AI agent has an identity token or ID token, and now needs to call APIs. Then you don't want the user to be prompted again. Right. And there is actually discussion about that in the auth working group on how to enable that. So it's not in the MCP authorization standard yet. I think there will be something, but you could use token exchange, right? You can take the ID token and with that log in, get an access token based on that. Saying, well, I have this ID token. I want to get that scope. Can you give me an access token?
Yeah, and I think there's generally a process here that you might be signed into one application, but you may not have the right scope yet to call the for AI to sort of do what it's requesting to do. So there's the concept generally of step up here, where you have an initial, the user's authenticated initially, but now the AI agent wants to do something higher privilege, and this is one of the things that our next code example is going to demonstrate, is how you sort of step up to do a higher privilege operation. So yes, involving the user isn't, it shouldn't be seen necessarily as a negative thing. This concept of human approval is important that the right level of access happens. So typically, I think the way we would potentially design the solution, Judith and myself, would be that you'd have an initial token, and that would be enough, a single user action to authenticate and consent. But only when there's a case where you need to do something higher privilege, then you involve the user again. And so you can get a blend between security and user experience, and step-up authentication has a number of ingredients to enable that. So you can enable like an easy login with a low privilege scope, and then require stronger authentication, stronger assurance for the higher privilege scopes. So it comes back to scopes that we were talking about earlier. What you can do is you can drive blend security and user experience using scopes. So to finish this slide though, I wanted to go back and say, once you have a stronger client identity, one of the things you can do, like here in this diagram here, is you could issue a stronger client assurance level, so that the API, the API now is a higher trust in the fact that the correct AI agent is present, and so using those claims, you could potentially allow access to extra data as well. So I hope that made a little bit of sense about the scopes and how you manage the user experience. But we just to come back to that question, yeah. So typically the user authenticator. So what we're showing in this example, in the demo that I just showed you, is that the user signed in with a pretty convenient method of email authentication, and and then consented to the AI agent. If the user is already authenticated, they could use single sign-on for that consent. So it's a nice simple action. And if you want to do something high privilege like buying stocks, then you could require strong authentication at that point and only at that point, rather than initially. So often stronger authentication requires more work by the user. They may need to get out their specialist mobile app or something. So so we've spoken about scopes, etc. So and I've finished speaking about strong client authentication. So the next concept that's very important in AI is human-in-the-loop constructs. So really, with OAuth and with access tokens, what you should have is that the access token enables least privilege access and also time-based access. And what that means is that the AI agent can its access can be reduced to zero standing privilege, right? Which is usually what you want. You don't want AI agents acting indefinitely in the background. And so to reactivate itself, the AI agent then has to request human approval again. And you can use your judgment on how frequent this is. And there's a few tools you can use. So we've already seen consent screens. We've already seen administrators approving the level of access when they set up trust. And there's another option you can use called CBA, client-initiated back-channel authentication. So in this example, there might be an AI component that runs within your back-end ecosystem that maybe produces reports or something, and when it wants to perform certain tasks and get a particular level of access token, you might require a disconnected user to approve the action. And this is something that CBA allows. It allows a remote user to be alerted and to grant access. And then the AI component can call APIs for a short time, do its job. And then, as we said, the level goes back down to zero standing privilege again. Okay, so the human-in-the-loop constructs, OAuth provides quite a few of those. And you can use them, and where you use them is up to you, depends on your use case. And final big ingredient I'm going to mention here is token exchange. So access tokens usually pass more than one APIs, especially in the world of MCP. And often the MCP server itself is an API entry point, and then beyond that are the APIs that do the real work. So this is going to be a common flow in the world of MCP and AI, we think. And firstly, the AI agent gets an access token, the opaque access token we were mentioning earlier. So the AI agent sends that, and a gateway can exchange it for a verifiable token, a JOT access token that the MCP server uses. And often the MCP servers will call upstream APIs. This might be your existing APIs that you've put lots of investment in previous years, or it could even be APIs of a business partner or something in some cases. And so there's another token exchange from the MCP server to the upstream API. If you look at the MCP authorization specification, there's quite a few details in there about audience restrictions and handling tokens correctly. So the ability to use token exchange is an important part of using MCP authorization. Okay, so hopefully by now you understand that with OAuth and MCP, it's not just a one-size-fits-all solution. You plug something in and everything works. There's building blocks, and you can choose the ones you need depending on your use case. So over to you, Judith. Judith, you're going to sum up.
Yeah. We're gonna wrap up. So what can you do now? We can go to the next slide, Gary.
Sorry.
So you can already get started. And I'll start with a low, medium sensitive data use case. As I said, it depends on the use case and the risk analysis on what you can do and how you can do things. But you can start experimenting. If you already have OAuth, you can select a use case with a low risk profile to get started. And we have also shown some ways to increase the confidence in the AI agent, use workload identities and similar identities to authenticate AI agents. Again, it depends on where the AI agent is running, which AI agent it is, but you can use these kind of ingredients to increase your security and implement use cases that handle high sensitive data. And when it comes to the future, things are evolving. So as we said, there is already discussion going on how to exchange ID tokens so that you can get a single sign-on without user interaction. But the main things that will remain is that you will need to authenticate the user and get consent. So if you have a single sign-on, you would need to get that consent when the user signs in the first time, for example. You're going to need to authenticate, or at least be able to identify the clients, and especially in high sensitive, like high security environments, you will need to have strong client authentication. And you're going to have to issue these privileged access token to your clients and especially AI agents. So those three principles, if you want to call them, they're going to stay. It's just going to be how to get there. That's going to change or improve depending on the use case.
Yep.
And with that said, we can go to our last slide. We have quite some resources. We're gonna extend those with new insights when we get them. So we have the AI agents in general, and we have, as we said before, the example on GitHub that you can try out if you want to get into the code.
Yeah, and what you'll see is that the code involved is, OAuth is always like this, that you do some thinking, some planning on, which building blocks you want to use, do some work on your scopes and claims, issue them all, a bit of work around user experience sometimes, as the questioner mentioned back there as well. And then ultimately,
but if you do auth, most of that work is in the authorization server.
Yeah.
So collecting the user consent, it's not something that you have to do in your application. It's something that the authorization server does for you.
Yeah, so OAuth done right is always, you don't write much application code, but it's all just about sort of it is a distributed architecture and things talk to each other and tokens flow, but ultimately it's a low code.
And it works for AI agents.
Yeah. So, and if you're not using OAuth already, I think now's a great time to sort of take a closer look at OAuth and the MCP authorization flow, and think about how you can integrate that into your systems. But there shouldn't be anything stopping you from progressing with AI solutions. And our resources should show you the way. And as I say, we're going to have another resource in the coming weeks around step-up authentication and go to show how to go from showing a user's portfolio and stocks to actually buying and handling the higher security use case. So
yeah, the webinar is recorded and will be shared with you after. Yeah.
Okay.
Some point afterwards when we have collected and downloaded the video.
Mm-hmm. Yes.
Any more questions? Well then, thank you so much for listening and check out our resources.
Yes.
Bye.
Bye.